here, I'm going to introduce to you a reference sheet that contains most of the equations or the definitions that you require in order to design spare gear. Okay, so what we have here, all right, so we have here the gear ratio and the torque ratio. I've introduced this already in the previous lecture, right? We know that we have velocity ratio where we have capital omega over small omega, and then we've said that for the wheel or the gear, we are going to denote everything here with capital letters. And for pinion, we are going to denote everything with small letters, right? So small omega, for example, is for the pinion, capital omega or for the gear. Small d is the diameter of the pitch circle. So the pitch circle diameter here is small d, and the pitch circle diameter here for this one is capital D. Okay, and so on. So the number of teeth here for pinion is small t. The number of teeth for gear is capital T. Also, we can calculate the torque ratio, and then it is the reciprocal of the velocity ratio, and eventually the gear ratio that we use for the gear set is whichever is greater than or equal to 1. And then we assume here that there is no slip between the pinion and the gear as mentioned earlier. So here, what is written here is all these definitions, like D is the pitch circle diameter of pinion, capital D is the pitch circle diameter of gear, small t is the number of teeth on the pinion, capital T is the number of teeth on the gear, etc. Okay. We have here what's called the base circle. You know how the base circle is important now, and why? Because the involute part of the tooth starts from the base circle. Okay, but for example, if we look here, so we have pinion, and then we have gear, and then this is the center point of the pinion, this is the center point of the gear, and then if you connect these two by the line of centers, then you have here R, small r, which is the radius of the pitch circle of the pinion. And then here you have capital R, so capital R, small r here. So the capital R is the pitch circle radius, of the gear. Then if you draw a line here that is perpendicular to the line of action, okay, so this is the line of action. So the distance between here to here is the capital R small b. Capital R small b is the radius of the base circle for the wheel or for the gear. And then you draw a line here that is perpendicular to the line of action or the pressure line. And it is small r sub b, which is the radius of the base circle, okay, for the pinion. Why I'm doing this? Because using the similar triangles here, or using these two triangles, you can find these relations. For pinion, for example, the radius of the base circle is equal to the radius of the pitch circle multiplied by cosine phi. And cosine phi here is this angle. This is a very important angle. Phi here is called the pressure angle. So phi here is the pressure angle. And the pressure angle here is, first, it's kind of the angle of the tooth. So if you, for example, measure the angle here, this is the pressure angle of the tooth. This is phi. Also, this pressure angle is the angle between this line here. This is, let's say this is the common tangent. So this is the common tangent because it is tangent to these two circles, which are the pitch circles. And between this line and this line, the line of action. So the line of action, the angle between the line of action, and this is the line of action, and this is the common normal, the angle between them is phi. Also, using the geometry, you'll find that this angle is phi, and this angle is phi as well. Okay, so phi is the pressure angle. So there is a relation between the radius of the base circle and the radius of the pitch circle using this relation, and also the same for the wheel. Okay, so you should know this. Circular pitch. circular pitch here, as I said earlier, if you follow the pitch circle here, so it is the distance between one point here on this tooth and the corresponding point on the next tooth. And then it is the circular distance. So it is along the pitch circle. So this is called circular pitch. And this is how you calculate it. So P sub C is the circular pitch. It is the, if you divide the circumference of the pitch circle divided by the number of teeth, so it gives you the circular pitch. They are the same for the pinion and the gear. They are equal. So the two gears, they mesh together, so they should have the same circular pitch. Okay. The module, we have introduced the module before. This is another way of representing the module sizes. So the module is the diameter is equal to the diameter, the pitch circle diameter divided by the number of teeth, either for the pinion and the gear. And again, if you have two gears meshed together, pinion and gear, they must have the same module. Okay. The module between 0.2 to 1, there is an increment of 0.1. So it's 0.2, 0.3, 0.4, etc. And for modules from 1 to 4, you have an increment of 0.25. So it's 1, 1.25, 1.5, etc. And here, greater than 4, we have 0.5. These are called standard proportions. So if you want to use standard proportions, so you should use a module, a standard module. Standard module means that you can go and buy this type of gear from the shop. It's off the shelf. Once you let them know about the dimensions and the module, etc., you can just buy the gear from a shop. So the diametral pitch, as I said, it is a USA standard. It is the reciprocal of the module, but the only thing is here is capital D and small d are in inch. Okay, and here is like how a representation of the sizes of the gears using diametral pitch. The center distance, okay, so it is, you have two gears, the distance between these two centers is the center distance, okay, and then it is this radius here, which is capital D over 2, and this radius here, small d over 2. So if you add these two radii together, so you get the center distance, right? Then there are lots of correlations here because, you know, for example, the module is equal to capital D over capital T or small d over small t, right? So from here, you can say that, you could say here, capital D is equal to the module times T and small d is equal to the module times small t. And then you can substitute these two here. So the center distance can be represented as a function of the module and the number of teeth, or as a function of the diameters. And also the gear ratio is, if it is capital D over small d, also you can play with these relations to find that the gear ratio is capital T over small t as well. Remember the PC, which is the circular pitch, is like pi capital D over capital T, or it is pi small d over small t. So you can just, again, substitute these two here, find D, capital D from here, small d from here, and then substitute to find that GR is T over T. And then there is a relation between the module and the circular pitch as well. So the module is equal to capital D over capital T, or small d over small t, right? And then the circular pitch is capital pi capital D over T, or pi small d over T. Okay, so you can find the relation here. So this D over T and this D over T is M. So the circular pitch is equal to pi multiplied by the module, right? Then you can just simply here replace the module of this equation. If you look at these two equations, replace the module here by PC over pi. So the module is equal to PC over pi, right? So if you replace this here, then you find that this is the equation for the center distance. And also, again, if you take T as a common factor, small t as a common factor, you can find the center distance as function of the gear ratio as well. Okay, so there are some calculations here, but I wrote everything on the screen so you can do this in your own time. Then I said the pressure angle. So you see, for example, we used to have 3 different standard pressure angles: 25, 14.5, and 20 degrees. Currently, we use the 20 degrees pressure angle as the standard. So whenever you make some calculations, assume, for example, if it's not given, so assume that the pressure angle is 20 degrees. It is a standard value. It is the addendum. It is denoted as capital A for the gear and small a for the pinion, and it is equal to the module. So if you want to, if you want standard gear proportions, you should have the addendum, which is the distance between here to here, as I said earlier. It is equal to the module. So we have another radial distance called the addendum. It is the distance between the pitch circle to the addendum circle, and it is equal to 1.25 times the module for gear standard gear proportions. So the working depth, H sub k, is equal to capital A plus small a. Capital A plus small a is the addendum for the gear, and then the addendum for the pinion. So this is for the gear and for the pinion. So this is the definition of the contact ratio. It defines the average number of teeth in contact during meshing cycle. So when these two gear come together, when they mesh together, if, for example, the contact ratio is equal to 1, if you have only one pair of teeth in contact. If you have more than one pair in contact, so this contact ratio becomes greater than 1. And mathematically, we can calculate this using this equation here. It's the length AB, okay, divided by circular pitch, PC, multiplied by cosine phi. Okay, or it is equal to, so the contact ratio is equal to Q sub A plus Q sub R over the circular pitch. So this is the circular pitch, which is pi capital D over T, or pi small d over small t. Okay, this QA and QR, they are defined as the arc of approach and the arc of recess. Here, the circular distance between this point and this point along the pitch circle is defined as the arc of approach, where these two teeth, they come together, they approach each other, and then they reach this point here in the middle, and then they start separating from this point. So from here to here, they start separating from one another, and this distance here is called the arc of recess. So we have the tooth thickness as well. It's the distance, circular distance from here to here. Remember that. So it is actually measured along the pitch circle. So it has to be from here to here. So this is it is the circular pitch divided by 2. This is the thickness of the tooth. Okay. The face width. So there are no standard proportions for the face width, but there are some recommendations. So the face width has to be greater than 9 multiplied by the module and less than 14 multiplied by the module. Guys, this is not meter, this is module, okay? So you multiply the module by 9, this gives you the minimum range, and then multiply the module by 14, this gives you the upper range. If you are using imperial units or the inch, so you can use this range, 9 over the diametral pitch or 14 over the diametral pitch.